Hello YouTube viewers, welcome to my show Computer Wednesday. In today's episode, we're gonna take a look at another integral part of a computer, the computer case. So you have to understand what and why it is in the first place. Now it makes computer transportable. Somebody has to manufacture the component, somebody has to sell it to you, the final end user. For that reason, a computer case plays a very crucial role. Apple could not just send you motherboards, cannot just send you CD drive, GPU and things like that. They have to package it in such a way that it becomes transportable. That is very crucial aspect. And to make it standardized, it makes every other component compatible with each other, especially needed if you have multiple manufacturers making component for a single system. Now it is what we call complete processing. Basically, this is why CPU is generally referred to as a computer case. Basically, whenever you see something like this, people call it, this is the CPU, the processing unit, because not only it contains CPU, it also contains GPU, either NVIDIA or Radeon series. The reason for that is all the computation done in the computer is done inside this box. So everything you have outside it generally is not for computation. They are generally either input or output system, like audio amplifiers or displays. So all the processing, generally it is tried to make sure in a scenario there they can ensure that all the processing is done inside this unit. So even if it fails, you can just replace it and your input and output will remain the same. For this reason, this is a complete package deal. Now, you also have to come to thermal management. Now, many of you have seen in recent days the rise of open bench air system. Basically, that's solely built for testers. You're not gonna buy a open bench system for your home simply because it's very dangerous. Not for the safety of you, but safety of the component, because if you touch any component and you have static charged, it will not ground properly and simply you might just hit on something. They generally use low voltage DC components, so it's very unlikely that's gonna kill you. And the components that can kill you, that is the power supply, it is generally encased in its own self with proper groundings if it's a good power supply. So inherently there is no danger to you, but from you to your component. For that reason, we like to encase it all. And it also provides a proper thermal path. Basically, air goes in, hot air comes out. It's very clear-cut path. So this is what and why we use it. Now we have to understand the whole reason why computer industry progressed so much is simply because Bill Gates' one unique decision that he could market DOS to anyone. After he sold it to IBM, the license would have been kept open, as in he could make money out of it. Now this opened the floodgate to every manufacturer who wanted to build something. They can build it and Microsoft will provide the software. Since IBM was developing on the software, basically building the application, building the business end things, consumer can also benefit from that infrastructure. So then comes the problem, if it's not standardized, how can you make sure your components like MSI or Microstar International, that is MSI, Microstar International or Gigabyte or Asus or any of these manufacturers can make components that will work with each other, because all of them can only make one component. Some may make graphics card, some may make motherboard. To make sure there is a standard to this, the casing standard was decided. Now this standard many of you are familiar with, ATX. Now this is a standard that is established by Intel, the processor manufacturer, and everybody agreed to it. That's why this ATX standard, as of now, as I speak to you, is the most popular standard for computers. Most of us have micro ATX. Now mini ATX is also catching on, since most people don't need that many PCI Express, and this nowadays can have almost everything, including PCI Express 3.0, PCI Express SATA, PCI Express based NVMe SSDs. So for all that intents and purposes, these two are very common. And if ATX standard would not have been created, we could not have reached a scenario where mass production of computer part by different manufacturers would have been possible. Because Intel locked it down and industry as a whole agreed to it, now we have computer industry. So standards are two types of standards. One, you have internal standards like components level standard, like this motherboard being the biggest component. It was the first thing that to standardize. Everything else was standardized around it. That's why you can see PCI Express came after old PCI Express, PCI. Before that there was AGI also. So for this reason, motherboard was the first thing to be standardized, to lock down, like this is it, we're not going to tamper with motherboard. Then everything else fall into place. Now, whenever you buy a cabinet in your shop or anything like that, especially on websites, they do, especially Cooler Master, Corsair, they do pay close attention to what they are mentioning in their system. Basically, if they say this cabinet can support micro ATX, do not think, even though it may look big, do not think you can put standard ATX. Now, standard ATX are generally workstation grade motherboard where they have a lot of PCI Express or lot of RAM slots, or sometimes flat out dual processor system. So for that reason, please pay attention to that. Either it's micro ATX or standard ATX, they are not intercompatible. And all the mounting holes are also standardized, so that's why you can mount a mini into this. Like, all this is this way compatible. You can't go this way, but you can come this way. Then we come to the external standard. This was done because of the rise of internet. Once internet became popular, once people realized that they're gonna put a lot of system in one place to make sure they serve thousands and millions of people, they come up with the standard that we call rack units. Now, rack unit, as you can see this representation, there are two width of rack, 19 inch and 24 inch. Basically, whatever you buy the server, they will tell you what you want. You want full width, basically 19 inch or 21, each have their own benefit. And in that unit, that's just the width. How about the height was determined by one U being one slot. So generally you can buy 1U unit, which is generally used for routers or firewall computers. Then you can buy 2U, which could be something more powerful, either more powerful firewall, antivirus, or network attached storage. And then you have 4U, which is full-fledged computer, generally used for supercomputings and things of that nature. There's another variant of this which we call blade computers, but that they are not as standardized as this. That's why I'm not talking about here. So if you are in a scenario where you are like, hey, I'm gonna build network attached storage system, I would advise you should look into U system, simply because even if you are building one now, you may build one another in the future, and in that scenario you can easily buy a rack and just put all of them in one place. That will help you simplify the networking system, and you may build your own network switch basically. For that reason, server system is the best. So this is the form factor aspect of it. Now we come to, okay, it's standardized. Let's talk about the material, how it's made. This is very crucial. Computer cases are the only thing that can outlast the electronics inside it. You may replace your power supply, not because it's bad or like, it stopped working, simply because it may not be powerful enough. My old Cooler Master power supply was 500 watts. I could not think it could have powered my current GTX 1070 graphics card, and with a bulldozer processor, it's kind of pushing it. So I had to bought something more powerful, 600 watt or 800. I'm not sure which one I have, but as you can see, everything could change. But your case, I have the same case for last 4 and 5 years, that I think I'm gonna use it for many years to come, simply because that's the most standardized thing in a computer. You can change everything else, but your case will remain. So for this reason, materials play a very crucial role. Now, first you have to understand there is design aspect to it and there is endurance aspect to it. Somebody may send you a steel case that looks very pretty, but somebody may sell you a steel case that is coated, looks very dull, but because it's coated, it will not rust, it will last longer. So there is a balancing act. Then we come to look and functionality. Nowadays you can see every manufacturer makes something very cool looking, but for a fact that if you buy this, it's gonna last. Not because this is bad or anything, but this is made out of either acrylic or glass. Both of them can shatter, get cracked, or don't have thermal endurance, and not to mention they will get scratched over time. Scratch on this will just look ugly. Scratch on this will make it so ugly that you have to replace it. Like, scratches on that is tolerable, scratches on this is not. So for that reason, you have to choose whether you want look or functionality. Now, of course, if you are building a luxury system, if you're like you want to show your system or something like this, is the best I found out. So you have to decide what you want, and be mindful the components inside can change, but your case will remain. Case survives, everything else dies. So for that reason, please be mindful before you buy the case. Now, what we expect in the future? Well, future is very custom. As I talk to you, more and more custom PCs are being built than ever before. Alienware flat out now have its own weird architecture, and every manufacturer makes their own weird architecture that is not traditionally standard. Even though they specify their ATX standard, as in mini ATX or micro ATX, they are not following the guidelines on the outside. As in, this is my personal favorite, MSI Nightblade. Now I love this system because this is the size of a UPS, but it has a mid-range to high-end gaming performance. And what they did, they had the motherboard, they put a very slim heatsink, capable heatsink but slim heatsink, and then they put a PCI riser, then put a graphics card somewhere else. Now all of this allows them to make a very extremely small case, but this is not standard because all the motherboard is designed in such a way that you're supposed to plug your PCI Express directly, not have an extension then hanging it out somewhere else. For that reason, this is a custom system. Even though every component used is a standard component, you can go out and buy it, but because it's using PCI Express, it will be classified as a custom system. But benefit of that is the most compact price to performance ratio PC I have ever seen. This uses server power supply to save money, because if they had made a slimmer power supply, they are more expensive, and not to mention they are untested compared to server power supply, which has been going on for 30 years. So, and not to mention, there are many unique abilities now will be unlocked, especially because the rise of artificial intelligence and neural network pushes hardware to a point where each processor, as you see in this, can reach a point of 3 to 400 watts of power consumption. Air cooling will simply not do it. In my last episode of computer cooling, I specified oil cooling is becoming more and more important. Now, to make sure that you can cool something that generates that much heat, either you have to use water or submerged. Now submerged has the benefit of, it keeps everything intact, it keeps everything cool, not just like whatever you are cooling, and it's inherently more simpler rather than having pipes. And if pipe fail, you're gonna spill water into it and fry your system. Here it cannot happen. This is a very interesting approach where they, instead of using oil, they're using a methanol based solution, which is very complicated, weird things they have mixed in. So it boils. So this is a two-stage cooling system. They don't have only water, only a liquid going around. They have liquid that boils off on the hot components, then goes to upper, and there is radiators here that will take the heat off and then dump it back. So it's like a heat pipe. Basically, they are putting components inside a heat pipe. So in future, we're gonna see a lot more submerged computer than we think, and I don't think there is any way in future that we're gonna have air cooling server systems, simply because the heat output of those systems are way too high, and not to mention it saves money by saving electricity. So even though messy nature, like people saying that it will make data center messy, yeah, people can handle that. We have surgery where you can cut open a human, change its heart, and put it back together, and man will walk again. We can handle a bit of oil spill. So this was my presentation on computer cases. I hope you liked it or learned from it. In that case, please leave a like. If you didn't, okay, dislike. And I would urge you to leave a comment what would you want to see in the next episode of Computer Wednesday. And I would urge you to subscribe. Please, I need 1000 subscribers, and press the bell icon as I make video every day. And as always, thanks for watching.